Exercise 3.4. Now, last term we talked about, by the way, don't forget to put the date up the top. Last term we talked about an expression. An expression is simply something like, this pen's not working, let's work. Say you've got 5t plus 4s take 3t plus p plus 2s. That's an expression because it doesn't have an equal sign. Say if you had an equals 10, then all of a sudden it becomes an equation. But let's just leave it as an expression like that. All these things here are called terms. So all these things, separated by pluses and minuses, are called terms. Now, if, and oh, by the way, these letters are called variables. So letters like X, P, T, and that are called variables. Now, if you've got terms that have got exactly the same variables in it, we call them like terms. So if you have a look, let me change the pen colour, say, to red. Actually, let's go to a finer pen. So this one here and that one there are like. These are like terms because both of them have got just the variable t in it. If we get another one, see S, this one's got S in it, and that one there has got S in it. That is also a like term. Okay, so 4S and 2S are like terms. 5t and 3t are like terms because the red ones here have only got T's in them, and these ones have only got S in them. P hasn't got any other like terms there in the equation. So like terms are simply terms that have got the same variables in it. So say we had 5t and 3t. Yes, they are like terms. If you had, say, the terms 2xy and the term 2x, they are not like terms because they've got to have all exactly the same letters or variables in it. This term over here has got an x in it, this one's got an x in it, that's fine, but this one's got a y in it, and that one over there hasn't got a y in. So if you had another couple of terms like 6m squared n and another term like 4m n squared, these are not like terms because the letters have to be exactly the same. This one here's got m squared in it, and this one's only got m in it. This one's got n squared in it, and that's only got n in it. So the letters actually have to be exactly the same, including the little powers on top. If you had something like the terms 3xy squared and the term 7y squared x. Now, these are actually like terms because the order of the letters doesn't matter. See, this one's got an x here and that's got an x there. This x is at the start, this one's at the end, but the order of multiplication doesn't really matter. This y squared, you've got a y squared in this term and you've got a y squared in that term. So the letters, the variables are exactly the same in both of these terms, so yes, they are like terms. By the way, with like terms, it really doesn't matter what the coefficient is, what these numbers are. So what I want you to do is have a go at number 1 on page 164 of exercise 3.4. Once you've done it, then watch some more of the video. Now, what I want to talk about is how you can simplify expressions that have got like terms. So say we've got 5x plus 3y, take x plus 7y, and that's an expression. You can actually simplify that. Now, the important thing to remember is you can actually add like terms. So if you have a look, 5x and x are like terms. So you can actually add them. So 5x, now this is a take here, 5x take x is 4x. Okay, so things that have got like terms, you can actually combine them together. This is simplifying. And 3y plus, see there's a plus here in front of that 7y, 3y plus 7y will equal 10y. So it's positive 10y, so plus 10y. Now, if you knew what x and y were, you could actually put the numbers for x and y in and work out an answer. So say you were told for this expression that x equals 1 and y equals 2, you could actually put those in here. And so let's see, 4 times 1 plus 10 times, now y is 2, 10 times 2. So it'll be 4 plus 20, the answer is 24. Now, in actual fact, with number 2, question number 2 in the exercise, what they want you to do is actually simplify an expression and put the numbers in and work it out. So they'll give you something like this. Let's do another one. Say you've got the expression 7x squared plus 4xy plus 8yx take 2x, and what you've got to do is work out what the answer is when x equals 3 and y equals 2. Okay, so you've got to simplify this expression, and then you've got to work out, well, what's it equal to if x equals 3 and y equals 2. So let's have a go at that. Let's simplify it. What like terms have we got? What terms are like to this 7x squared? Well, there are actually no other x squared terms in here, so there's nothing to add on to that. You just put 7x squared. Now, we've got 4xy and 8yx. Now, the order of the letters doesn't matter. 4xy is a like term to 8xy because it's got the same letters, the same variables. So we can add those two together. So 4 plus 8 is 12, so it's plus 12xy. Normally we put the letters in alphabetical order. X comes before y, so we put x and then y. And then take 2y. There's no other like terms that have just got x in it that you can add that minus 2x to. Now what you do, we've simplified it. We can actually put, wherever we see an x, we can put a 3 in. Wherever we see a y, we can put a minus 2 in. So let's actually have a go at that. So it's going to be 7. X is 3, so 7 times 3 squared plus 12 times x is 3, y is 2. Take 2 times x is 3. So let's do it. 3 3s are 9. 7 9s. What are 7 9s? Oh, I should know this one, shouldn't I? But I'm going to cheat. 7 9s. By the time I get the calculator out, I should have worked it out. 9 times 7 equals 63. Oops, that's one of the tables I don't know very well. 63 plus 12 times 3 is 36. 2 times 36 is 72. Take 2 3s are 6. 63 plus 72 would be 135. Take that, I think it's 129. Yep, 129. So what we've done, we've simplified this expression by adding like terms, and then we've substituted the numbers in. X is 3 and y equals 2. Now, you should be able to do number 2. You should be able to do number 2 on page 165. In actual fact, you should be able to go through and keep working through the rest of the exercise and see how much you can do. That would be great.